Hey guys, my name is Marek and welcome to my channel. In today's video, we are going to go through Model Context Protocol, what the MCP actually is and how it works. We go through concept of mixture of experts, then we will see how training and learning of LLM using vector store actually works. And in the end, I will introduce you to my new project I will be working on. It's called PrivaMine. So let's go. So what is actually a MCP, Model Context Protocol? At its core is a structured system for managing how AI agents communicate, retrieve memory, use tools, and coordinate action across different sessions. So it is not a model, it is not a tool, it is a protocol, a set of rules and architecture to make AI agents autonomous, context-aware, and capable of acting across time. So you might be asking, why do we actually need that? Why do we need MCP? So today's LLMs, even the best of them, live in a moment. They respond to prompts but forget who you are 5 seconds later. I'm sure you all are very familiar with that. So they don't persist knowledge across tasks unless explicitly designed to do so. And so we prompt engineer endlessly, wasting time and tokens to remind the model what it should already know. And MCP changes this by acting as an operating system behind multi-agent AI. It introduces the context injection. Agents don't just guess the task. They know the user's context from a vector store dynamically injected into the prompt. Tool usage coordination, agents calls APIs, trigger workflows, for example via N8N, use browsers or generate images, audio, or their own. MCP defines how to do this safely and predictably. Memory recall, rather than reprompting, MCP-powered agents access a memory backend. This could be long-term personal data, CRM entries, knowledge bases, or dynamic notes from prior sessions, and then state persistence across sessions. Agents maintain long-term goals, tasks, identity, and preferences over time without retraining or reprompting. However, GPT just made an update as of April 25 that all your chats are now remembered. I'm sure you just experienced that all of a sudden GPT knows context and you don't have to explain that much as it remembers what you guys been talking about recently in other chats. Like in general, this is what we want, this is what we're looking for, this sort of experience. But the catch is it all lives in OpenAI servers, and we probably, if you are like me, don't want that. But more of that later down in the video. So MCP typically involves 3 major components. One is the agent, a large language model acting as the brain running in the loop. Then 2, the MCP core, a logic layer that injects context, routes decisions, coordinates tool usage and memory calls. And then 3, the memory layer vector store, uses embeddings to fetch relevant documents, past conversations, or user data. Vector databases or local Facebook AI similarity search powers this. So FAI is a library to efficient similarity search and clustering of dense models. So just to explain, if your AI agent is a smart assistant, then MCP is the full intelligence stack behind it. To recap, it has a memory, vector store, action, tool usage, awareness, context injection, persistence, state tracking, and autonomy, decision routing. So if you recall back in the day, it's just like HTTP turns static web pages into interactive web. MCP turns single response chatbots into intelligence agents. So this is the direction the future is heading: smarter orchestration of agents that think, remember, and act like people. So we can actually take a look at this GitHub in here, which is of the Model Context Protocol servers already ready to use. It's just a lot, if from the official servers to third-party service integrations. Like it has so many servers already to be available for usage. It really is interesting, and I think there is no limit what you can build right now. So when you start playing around with that, let me know in the comments what you are actually working on. That's very exciting. Yeah, so the next topic I would like to go through is the mixture of experts. That is very interesting also, and this comes on the surface very much with when the DeepSeek arrived. DeepSeek is it was the, let's say, first model who hit the waters with the architecture, and it's not that the architecture wasn't like known or something. It was, but it wasn't actually put in motion at scale like that. Most people think in general that LLM is a giant monolithic beast, like dense, heavy, and fully activated for every single request. But what if we could make them smarter by being selective? And that is a mixture of experts and architecture strategy that makes LLMs faster, cheaper, and more efficient without sacrificing power. So it's like assembling a league of specialists, but only calling the ones you need. So let's talk about what is a dense model. The definition is that dense model is simply a neural network where every neuron is connected to every neuron in a near layer. So in traditional dense models like Llama or ChatGPT, all parameters are activated for every prompt. The model computes across its entire network, and this leads to massive compute usage even for simple tasks. Think of it like asking your entire company to attend a meeting just to write an email. So the dense model is you ask one question and every neuron in the brain fires, and a mixture of experts is like you ask one question and read, and the only relevant part of the brain activates. So the benefits are immediate. So one is the efficiency, fewer computations, faster interference, and a lower cost. Two, scalability. You can scale to hundreds of billions of parameters, but only use a fraction per API call. Then specialization. Each expert can specialize in a domain, for example, math, legal, medical, coding, etc. And then sparsity. If the model is sparse during runtime, most parameters they're inactive. So the next wave of LLMs won't be denser. They'll be smarter, selective, specialized, and efficient. However, there is one more denser. It's called Behemoth, but let's talk step by step. Meta actually introduced recently the new Llama 4 series, which includes 3 models: Scout, Maverick, and Behemoth, and these are all mixture of experts architecture. So the Scout has a remarkable context window up to 10 million tokens, which is very interesting to me also, because when I start using Claude Anthropic console for coding in the October 2024, it had only 200,000 token limit window, which was very hard to work with because there wasn't any contextual memory for the another chat. But right now, look at that. 6 months later, we have already a 10 million token context window. That's crazy. The total parameter for Scout is 109 billion, and active parameters when talking to it is 17 billion, with the experts of maximum 16. So usually there is, let's say, only few experts, even from this total number used for that query. Then there is this Maverick. There should be, or they say it's comparable to a leading model to OpenAI 4.0. Excellent in coding and reasoning tasks. This one is 400 billion with a 17 billion as well active parameters and 128 experts. And then lastly, as I mentioned, we have this Behemoth, which is over 2 trillion parameters in total, which is supposed to be even bigger than GPT. And active parameters for this guy is 288 billion with 16 experts. Very interesting, but this is currently still in development. Yeah, so the next thing I would like to go through is how LLMs learn using vector stores. LLMs don't learn like humans do. Once a language model is trained, it's static. It doesn't learn anything new after training. No matter how many times you ask it something, it won't actually remember you unless you build something on top of it. You give it a memory. And that's what a vector store is, an external brain that sits next to the model. It doesn't change the model itself, it feeds the right context at the right time. So a vector store in general is a special type of database designed to store and search embeddings, which are just numerical representations of information. So this is how it actually works. There's a text or image or code, whatever, and it's passed through an embedding model. It's then converted into a high-dimensional vector, a numerical representation, and these vectors are stored in specialized vector database. When the user asks something, their query is also embedded, and the database returns the most relevant chunks based on cosine similarity or other distance metrics. And these chunks are then injected into a prompt, which is RAG, using RAG, retrieve augmented generation, and now the model has a real-time knowledge or context. So models in general don't need retraining to get smarter, they just need better memory management. And this is the future of personalization, and this is how agents will start remembering what you like, who you are, what you built last month, and where you left off. And this brings me to the introduction of my new project, which I would like to start working on and will be working on. It's called privamind.com. It's the short from private mind. So my vision is that it should be a framework designed to orchestrate local LLM alongside big LLMs, but with one key difference. Everything you do with your AI assistant stays local, right? All your conversations, all your embeddings, or your memories stored locally, vectorized, and owned by you. So the vision is that the local LLMs handle everything from quick commands to deep work. They write your notes, drop emails, summarize documents, do research, write code, guide your thinking, basically your everyday work like you are used to with your ChatGPT or whatever. For heavier tasks or complex reasoning, your local assistant can reach out to the major cloud model, pull back insights, and store only what matters locally and privately. Your assistant grows smarter over time and learns your preferences, recalls every detail, and never leaks it to anyone. It will have the fully personalized memory. It should have voice-enabled interaction and secure encrypted context retrieval, and work across devices you wish to connect to it. And eventually, when the humanized robot comes into the market, it should be able to connect with them as well. So it's a real embodied personal intelligence. So why I'm actually doing this? For me, is not just a cool project. It is a response to the current landscape, because right now we build things on top of GPT and others, but every word you say becomes their dataset. I want to flip that, so you own a control. You own the memory layer. You control the access, and you decide which models to use and when. And your assistant gets smarter for you, not for anybody else. So at the moment, PrivaMind is just the first step, a placeholder, a signal, a starting point. But I would like to start continuously working on it, because I found it very much important thing to do right now, since we are in a place or a time where we're actually giving up all our thoughts and everything into the servers of the company, which is, if you like, we've been doing that with the Google for sure, but I mean, look, right now we are interacting far more different way, and we give up much bigger chunk of our brain. It's basically our digital copies right there. So those are the reasons why I want to work on this. So what hardware can PrivaMind run on? And it's not generally about the hardware. It doesn't have to be local. It should be working also on your secure cloud if you wish to, obviously, but let's prefer the local hardware first. PrivaMind will be run on your local machine, whether that's a Mac Mini or Mac Studio, custom built computer, or Lambda AI workstation. The more capable your hardware, the larger model you can run, and more reasoning power it will have. But here's what matters the most. The PrivaMind framework works the same across all setups. No matter the model size, your local AI agent acts as a core orchestrator. It manages your memory, handles tasks, and decides when to reach out to the larger cloud model for extra firepower. To maybe go a little bit deeper, my vision in understanding this should be that the local LLM will have access to the memory and will be only talking to the big LLMs cloud solutions when it needs to enrich and doesn't have the data to work with, or doesn't have the weights to work with your tasks. And it can actually do with the multiple ones. It can just fire the questions to the multiple ones, depends on what you are actually doing, but he gets all the information, process that, store it, and he will learn and create this context memory layer for you. But the cloud solutions will have least, or they have a fractional understanding, so they stop collecting all bigger picture about you, and that's the vision. So fingers crossed and see how it works actually. So I'm excited to see. Now, core part of everything is where these memories, where this vector database going to live, and that as far as I'm aware, we don't have anything at the moment which is more than just some SSD disk for individuals, maybe some enterprise level disk for sure. But let's talk about the common users and individuals who would like to use that. So SSD disk is the way to go. But in generally, to understand how SSD disk works, because there is also a wear out problem. So I would like to talk about the memory storage a little bit to understand what we are actually dealing with. So a SSD, the solid state drive, is generally a brain made of tiny electrical switches, right? So each switch can store 1 or 0 by tapping or releasing electrons inside microscopic cells. So when electrons are trapped, it's a 0, and when they are not, it's a 1. So this data stays put even when the power is off. No moving parts, just pure electricity and precisions. So over time, though, the material inside those cells wears down, and this actually means that in general, the disk will be not usable in a time. Every time the data is written, a little bit of wear builds up, and that's why SSDs eventually wear out, usually after hundreds or thousands of terabytes written, or let's say 5 to 10 years of regular use. The modern SSDs are smart. They spread out data evenly to make them last longer, and most people never hit the limit in normal conditions. They're fast, silent, and surprisingly durable. So SSDs are now modern. Is how modern machines remember. We are using them daily, and the reason why I'm saying that even if you use the PrivaMind with your Mac Mini or whatever solution or computer you would have, you still need to store these, and you would be using probably this SSD disk, and it's going to be very integral and core part of that, because it will store all your thoughts and data. So just to give you an understanding what actually is needed, in general, let's say you start with the 2 terabytes, okay? This is when, let's say, your AI agent logs everything daily. You interact with it daily, let's say 24 hours a day. And when it stores notes, chats, and embeddings only, it is probably around 0.65 megabytes a day. When you add more voice memories, transcripts, meetings, probably let's say up to 100 megabytes. and video logs, webcam snapshots, let's say 45 megabytes a day. So in generally, you see, when you will be continuously interacting with it, you would probably have 124 megabytes per day or something like that. So that means that with the 2 terabytes, you're looking for 16 years of memory without deleting a single thing. And that's more enough for the full career, digital journey, and entire life of your AI agent. So even when there are some heavy days, you still be over a decade of continuous logging. And that means that my point is that it's not a problem with these disks. They can handle a lot, even though when you will be talking every day with the framework, with PrimaMind, storing daily to your 2 terabytes SSD disk, and it's quite convenient and not that expensive to purchase. The 2 terabyte disk costs up to $200, I believe, and if you change it every 5 years, it's just fine in my opinion. Let me know what you think. So in generally, I would like to also, or we can compare this PrimaMind thing to your Tron identity disk in the real life. I'm not sure if you see the Tron Legacy movie, but I recommend everybody to watch that. There is actually a new one coming in October with Jared Leto. I like that. However, it's a really nice analogy on how these disks are important. So your disks is you. It stores a personal embeddings, your contextual knowledge, your conversations, preferences, workflows. Is your interface into your digital self, your AI assistant's memory and reasoning path. So basically, if someone steals it, they steals you. And exactly like the Kevin Flynn, the main character in a movie, says, like, this is your disk. Everything you do or learn will be imprinted on it. However, it's not a sci-fi anymore. It's just the agentic memory protocol grounded in real tech, or it could be at least. And just as in Tron protocol, it was very much the integral part of everything. I think we are heading into an age, or we are in an age where this should be happening, and we need to own our own data. Because I think, as I said, it's unprecedented how we are actually giving up our brain to the servers of the corporations like GPT and stuff. Not that I don't like their work, I do. I would like to pay for the big train model to retrieve what I need and just store it into my disk. And that is something which we all should be thinking about. And I will be doing my best to figure out how to do that as efficiently as possible. So if you like to be updated, keep on watching the videos. I'm always available for a private message. Please reach out anytime you need if you would have more questions. And thank you for watching, to stay till the end, and I'll see you guys in the next video.